Welcome to today's NFDI talk. This episode is about Jupyter for NFDI, a central Jupyter hub for the NFDI. Today's speaker, Björn Hagemeier, is co-lead of the division Large-Scale Data Science at Jülich Supercomputing Center and heads the group of Data Management and Analytics. This group operates various services related to data management, access to high-performance computing resources, cloud computing, and federations, including the Jupyter Hub that lays the foundation for the recently started NFDI-based service project Jupyter for NFDI. Before the talk of Björn Hagemeier, Andre Giesler, service steward for Jupyter for NFDI, will give us a short introduction about Base for NFDI. So the floor is yours.
Okay. So, can you see my screen?
Yes, perfect.
Yeah. Hello, my name is Andre Giesler from Base for NFDI. As we are about to hear a presentation on Jupyter for NFDI, one of the currently funded basic services of Base for NFDI, I would like to take the opportunity to give a brief overview of Base for NFDI and the basic service concept there. So what is Base for NFDI? Base for NFDI is a joint initiative of all 26 consortia. Our goal is to establish reliable basic services that follow the FAIR principles of research data management. What do we mean by such a basic service? A basic service should initially be able to be used by as many consortia as possible. It should also be interoperable with international standards and services if these are available. And ideally, a basic service should also build on existing solutions in order to utilize their achievements and synergies. The development and fostering of these basic services, which is divided into different development phases, requires a framework which Base for NFDI provides. The first consultation on potential basic service ideas usually starts as soon as they are defined in the working groups of the NFDI sections. Accepted and funded basic services are supported over several consecutive development phases in order to increase the successful completion of the services. During the development phase, Base for NFDI supports the service teams with expertise in requirement analysis and user studies if the basic service teams requested that. At the end of these often multi-year development phases, the basic services will be integrated into an NFDI-wide portfolio that will be available to all users in NFDI. The base team also provides support in the training management of users, in communication with stakeholders in NFDI, and of course in the transparent allocation of funding resources. The overarching goal is a high level of acceptance of Base for NFDI services in the NFDI landscape with the greatest possible consensus among the consortia of NFDI. At this point, it should be noted that Base for NFDI will not be the operational provider of the services. Base will neither host or maintain the services. Base sees itself more in the role of an initiator, a facilitator, or broker of the basic services. What do we mean by the definition of a basic service? So this is a technical organizational solution that can typically be described with the following characteristics. For example, storage and computing resources, were offered software analysis, data processing tools, and workflows can be included in a service. However, functionalities such as user support and training management are also to be understood as components of a basic service. In any case, very different services with different depth of technicity are conceivable as basic services. Furthermore, the following requirements should ideally be taken into account when a service idea is created and filled with life. A basic service should create and formulate added value for the users. It should bundle existing solutions in the consortia and build on them. In the large NFDI landscape, value should be placed on scalability and sustainability. Acceptance in the research communities should ultimately be trackable through usage metrics so that KPIs can be formed. These requirements are also reflected in the application criteria that must be met by applicants in the individual funding phases. Depending on the development phase, a minimum level of approval is required from the consortia. For example, the approval of at least 50% of all consortia is required before service can move on to the integration phase. The technical readiness level of a service should, of course, be sufficiently high before it can be moved on to the final funding phase, the operational ramp-up phase. Of course, there are many other criteria defined by Base4NFDI. The aim here is to simply show that requirements such as interoperability and sustainability of the services become more important as the development phase progresses. There are currently 6 funded basic services in our portfolio. Soon there are even 7. IAM4NFDI, which is currently in the integration phase, was the first to enter the base project. This is a service for setting up the NFDI AI, so to speak, the big A in fair-oriented research data management. PID4NFDI and TS4NFDI were the next 2 candidates, and as the names already suggest, they provide persistent identifier and terminology services for the broad use in NFDI. All 3 services have already been presented in NFDITalks. 3 more services have been accepted since June: data management plans, knowledge graphs infrastructure, and of course Jupyter4NFDI. The latter is now presented in detail after this short introduction, and more information on basic services and Base4NFDI in general can be found on our website. Now have fun with the Jupyter talk, and I hand over to Björn.
Yes, thank you very much, Andre, for this short introduction, and also thank you very much, Natalie, for the kind introduction of my person earlier. I think, Andre, you need to stop sharing before I can start sharing.
Okay.
At least Zoom tells me so. That looks better. Okay. That. Should do it. All right. Yeah. So again, my name is Björn Hagemeier. I lead the project Jupyter4NFDI, which has started last month. So we are in month 2 of our journey, going through the phases of initialization, integration, and ramp up for operations. I will briefly because it was not quite clear um, whether the audience knows Jupyter intimately or not. Have a short summary slide of what Jupyter is. I will also later have a demo, so you get a hands-on feeling of what it should like. Other than that, I'll present a bit of the history of how the project came into being, the status of the project, even though we're only in month 2 right now. So bear with us, have a bit of patience until you can make use of the full infrastructure that we intend to put in place over the course of the project. And then an outlook of things that may not be covered or will not be covered by the initialization phase, but only during later phases. But the vision we have in mind, where the journey will go. Okay, so brief summary of what Jupyter itself is. So Jupyter's mission, and thank you very much Bernd Flemisch, who is also present here today for providing the content for this slide. The mission is to support reproducible, exploratory, and interactive computing through a collection of standards, a community, and a set of software tools. So reproducibility in this case means I have done something and I want other scientists, researchers to be able to follow along or redo the same experiment and come to the same results and conclusions. Um, Naturally, we all know there may be deviations from this, but in terms of quality, the results should be reproducible. Exploratory in the sense that I have and this is supported from my point of view by the interactivity of the tool. I have a tool and probably most often a set of data that I want to work with. I have a set of tools, typically software and libraries with which I can work on the data. And I want to explore the data now using these tools. And I want to do this interactively because, you know, some findings may inform the next steps. So this is the way we see this. And that there are a set of core concepts associated with the Jupyter landscape. First and foremost, probably is the Jupyter Notebook, which some may know from history used to be called IPython notebooks, which were somewhat interactive Python sessions running a so-called kernel. These Jupyter notebooks are typically hosted in a web browser such that they can be used from anywhere. And these comprise a combination of documentation and programming code, meaning we document for subsequent users of this notebook or for anyone who wants to read and follow along later on what we do here. This is not necessarily documenting the code itself and what it does. This can also be done, but also the method at a more abstract level and what we do with the code and why we invoke certain things, why we take certain steps with our data. So this is one part, the Jupyter notebook. I've learned to say Jupyter, not Jupyter, even though the Y, invites to say Jupyter. So JupyterLab, that's essentially a collection of Jupyter notebooks, and I extended this with and data. You can do partial data management in your JupyterLab. You can imagine it to be something like an IDE, an integrated development environment, where you have, your file browser having the various Jupyter notebooks that you can open and run. You can run various kernels in this. So that can be a Jupyter, a Python kernel, an R kernel, various other kernels. A Python kernel can be run in various virtual environments such that you would have, depending on the kernel that you choose, different tools available. So this is the JupyterLab. And then a Jupyter Hub is a multi-user web-based Jupyter environment such that you can go to a single address or multiple users can go to a single address and invoke their JupyterLabs or start new JupyterLabs on this infrastructure. So this then avoids the need for the individual user to install software. It allows for sharing resources, and essentially I consider it to be a facade for JupyterLab and maybe other backends like RStudio and maybe some others. And this, you will see later, depends on the settings you do when you create such a lab. Okay, a brief history of Jupyter at JSC and in the NFDI consortia. So when applying for this base project, there's a process associated with this, with it, of course, that includes a feedback round of questions asked to the consortia, which reply whether such a service would be useful for them, whether things are already ongoing in their consortium, stuff like that. So the reports were that around 1/4 of the consortia have comparable services, whatever that means, already in use. That's good. So there's a good portion of consortia who would be able to make use of such a service and maybe also make use of a common service to join forces actually and maybe get a more sound service, a more stable service, maybe with more resources, easier availability to resource or easier access to resources. So that's good. A staggering 2/3 of consortia actually do see a need for Jupyter or comparable services. So this is even more important, a more important argument in favor of a common service, because that means that 11 of these consortia see a need but don't even have a service yet and may make use of such a common service made available to all of the NFDI consortia. And some of the consortia reported that they are already in the development of something like Jupyter service. What I didn't put down here was the dependencies between these answers. So, and as with any good survey, there was some room for comments. So we received some very constructive comments, certain questions that were asked, why we intend to do certain things in some way, in one way or another. We will take this into consideration, and we considered most of these comments very constructive and will answer them as time progresses and as the project goes on. So the reason why JSC had been asked to lead this activity, this project, has been that we've been quite active in this area for the past 7 years by now, in making available HPC and cloud resources that we run and operate at JSC, but also at other GCS, the Gauss Center for Supercomputing's partner centers. That's the LRZ in Garching, as well as the HLRS in Stuttgart. So we've gone through some, or we've made some experience in making available a variety of disparate resources, which we found to be a good foundation for the basic service of the NFDI. And you'll see that in the history, as time progressed, put this on the foundation of a rather stable Kubernetes cluster that sometimes seems to have self-healing facilities. So when we have an outage in one component, it comes back automatically, things like that. So we have a very good infrastructure built up already there. And a recent development, well, of the past 1 or 2 years, has been the Outpost spawner that is able to integrate external resources via a rather thin API, such that any resource that wants to connect to our infrastructure can be integrated via this Outpost spawner and the Outpost API. And we see this as an asset for the base service. So Jupyter at JSC, as I said, 2017, 2018, we've We immediately started with authentication and authorization because it was our means to access HPC, so high performance computing resources, on which we had the Unicore middleware already running, which does a lot of good things at JSC. And it was good for integrating it with the authentication layer such that we would only need a single authentication at the web level of the Jupyter Hub to use also on the Unicore level such that a user authenticates only once and can use this authenticated session down to the level of the high performance computing system. So, and then we progressed and improved usability and improved, in particular, the usability on the high-performance computing systems, added some features such as remote desktop, which is good for interactive visualization of ongoing HPC jobs. We do make ample use of it in terms of workshops and trainings, such that we also have quite some training material readily available to do trainings on HPC resources, but also trainings on Jupyter itself and the use of it. We switched to Kubernetes. I already mentioned it on the previous slide around 2022, 23. Switched to JupyterLab 3 by that time, and nowadays also to just recently to JupyterLab 4. We also support community JupyterHubs, which I hope I have on the next slide. Yes. So we use this Kubernetes-based infrastructure to run multiple JupyterHubs for various communities. So two screenshots here on the left, one from the unique. So that's the Jülich quantum computing infrastructure. We call it quantum computing in your browser. Of course, the browser is just the window into the quantum computer. And the other one to show mostly that we're not limited to this style that always looks rather the same. The Center of Excellence in Combustion that has integrated the Jupyter system to some extent into its website. So we have that, and as you can see, there are multiple other services that run Jupyter, and the most recent addition to this set is Jupyter4NFDI, of course, which I'll show a demo of later on. So the relation to the NFDI section, common infrastructures. So the working group Research Software Engineering started meeting as early as June 2022. There may have been earlier meetings, but this has been as early as we were involved. So there were regular meetings about Jupyter and what one could do, about the developments regarding the opportunity to get basic services funded. We also had meetings where we invited core developers of the upstream Jupyter, so the Jupyter guys who followed with interest, and we are also every now and then in contact with added features or feature requests that we need for our infrastructure that they can then integrate upstream such that we don't have to have a fork of the code and maintain that. And typically they are open to these additions, of course. And then in 2023, between roughly February and August, we started preparing the base proposal. We were successful on the second submission this February and started, as I already mentioned, last month. So we are roughly where the red line shows in this Gantt chart in month 2, middle of month 2. Nevertheless, we already reached milestones 1.1 and 2.1, which is the availability of the central Jupyter Hub. So we have that set up, which is good, right before the big summer break that we'll probably have. And we also have initial resources of JSC, cloud resources in this case, added to this central hub. So, and this will then be the starting point, as you can also see on the dependencies, for further developments. The integration of additional resources, we've put it towards the end of the project, but there's already stuff going on in this direction when it comes to onboarding some others of the partnering sites within the base project. Okay, so the partners, I think I haven't mentioned them yet. So is JSC, Jülich Supercomputing Center, as already, that's my home organization, GWDG in Göttingen, CIDS at the Technical University of Dresden, GESIS in Cologne as well as Mannheim, University of Stuttgart, and the MPCDF, the Max Planck Computing and Data Facility in Garching near Munich. So, and the roles of the participants, so CIDS is an NHR resource provider. That's a new term here, the Nationales Höchstleistungsrechnen. The association is also present as a member of our team, which means we have a link into this NHR infrastructure and would in the future then in later phases of the project also see additional NHR resources provided through Jupyter for NFDI. We have GESIS who mainly deal with the user representation and the use cases and outreach activities. They do run, nevertheless, an infrastructure which is GESIS Notebooks, part of mybinder.org, if you're interested. We have GWDG, who are also active in the IAM for NFDI project, and who are acting in terms of IAM integration and also as a resource provider. We lead this activity, our technology provider when it comes to the whole, running the whole stack and running it stably. MPCDF as a resource provider and the University of Stuttgart dealing with the connection of external resources, linking data sets, and similar things. So what we can imagine, the map on the right shows it is the integration of these resources with a central Jupyter Hub. I think I don't have it on any of the slides, and this may be a question coming up. Single or central infrastructure may be a single point of failure. We certainly want to try and avoid that. Central can also mean there is one address you access, but it can be multiplexing onto various backends such that single points of failure would be avoided to the extent that at least the central service would remain available. This will not be possible certainly for running sessions or so, which we cannot easily migrate from one system to another. Yeah, so the connection of external resources, part of the research software engineering working group's activity was to create an inventory of available Jupyter Hubs, Jupyter installations in general within the NFDI or in the German landscape, if you so want. This is available on nfdi-jupyter.de. Some of these, and there's a screenshot here on the lower left, and you see GESIS Notebooks and Jupyter JSC. Some of that will immediately be integrated or have already been integrated, like this Jupyter JSC that you see here. What we also noticed as part of the preparation of the proposal was that some of these, and there's, I think, a dozen, between 10 and 20 Jupyter Hubs listed in this inventory. Some of these are fenced off behind virtual private networks, have access restrictions in terms of which consortia or individual consortium can access the resources. We try to avoid all this and have a general service offering for everyone. And of course, always others are welcome to join. So if there's a Jupyter Hub that's not listed on that website yet, we're happy to also list it there. But this is more of an RSE activity rather than the project's activity. So relation to other basic services, certainly IAM for NFDI will play a role because we need to know who is accessing our infrastructure. This determines what resources they will even get to see because of the number of resources that we are able to integrate. I only mentioned a few potential candidates so far. Users would be overwhelmed with the full set. So our idea is to query or retrieve information from the identity and access management that allows us to determine to which resources a user would have access, and then show a restricted set that helps them make the right decisions and configurations to make it easier for them to access their Jupyter Lab or RStudio or homegrown image, which is also possible. Yeah, then we have PID for NFDI. So the idea is, of course, fair to support fair digital objects, which could be notebooks that someone has created and references somewhere for others to review and rerun. This is also the original idea of the MyBinder infrastructure, of which GESIS is a member. So we have ideas of doing this. We have no technical implementation yet, but we're only in month 2 so far. Data may play a role. Data may be referenceable and resolvable. So PIDs may resolve to data, and the service may need a means or will need a means to resolve these references. So we have ideas there to link with PID for NFDI. And multi-cloud, it's not yet or not a running project or infrastructure, but maybe coming in the future. We see the interaction twofold. Twofold. For one, as an external resource, of course, cloud resources that are available can easily be integrated in Jupyter for NFDI, as well as a potential hosting environment for the central service, or maybe if we have multiple locations of this multi-cloud in geo-redundant locations, then the central service can be split in various places such that we can ensure a higher availability of it. The diagram here on the lower right shows this embedding in for one on the right, the Jupyter ecosystem, and to the left with the NFDI in general. And then the numbers are the work packages of the project, actually. Okay, community support. So almost immediately upon approval of the project, we've been contacted by various groups coming from various domains. So the NFDI for culture, for instance, want to host a comprehensive toolbox for sheet music analysis and visualization on our infrastructure. NFDI for biodiversity contacted us for the integration of already existing Jupyter-based toolboxes or a toolbox in Jupyter for NFDI. And from the Daphne for NFDI, we received a request for the integration of a FEL software stack with high-performance computing systems. Naturally, that was even before the project had started. We had to, put them on hold for a while until we were ready to really answer this. We also expect additional communities to be interested in our activity and to support them then later on. Okay, what is available already today is the initial Jupyter Hub for the NFDI. It provides minimal cloud-based resources, so far only at JSC. The more RAM you choose, so the more main memory, the less wall time you will get until your Jupyter Lab will be shut down again. We do allow for custom images and have a set of configurable extensions and kernels. If you want to visit it, you may want to wait until I'm done with a brief demo, but you could do so today. Now let me check whether I can. Nope. Switch. Pause share. No, I didn't want to. So I want to pause share and then it worked well earlier. Probably need to edit here. This thing. Don't we see anything? There.
It works all good.
Yes.
Yeah. Okay. So what you see here is the hub nfdi-jupyter.de. You could call it, and click on login. We also see that there are already users on it. It may have been myself over the course of 24 hours. We go to login. You would typically get the well-known "Where are you from?" page. I have a pre-selection of Jülich here, of course, and for the sake of time, I'm going to cut it short. So, will this work? It worked earlier, so I'm hoping for it to work now. You can test so many times and still not be successful. Other app, sorry. All right, so we are welcomed with our cryptic user ID at the top right, where we could log out. We don't do that, of course. We get links to the JSC status page, some generic documentation on Jupyter JSC for the time being. It's not been customized for NFDI yet. Some additional links to various sources of documentation on Jupyter itself. We can create a new Jupyter lab and give the lab a name. That's quite easy. The default selection here is JupyterLab 4.2. We could use JupyterLab 3.6 or a custom Docker image. In case of such an image, you can have private ones and add additional credentials to download them. Even this example string here works, so that's also been tested. I want to go with the JupyterLab 4.2, which gives me an opportunity to also select kernels and extensions, of which there are several. Going back to the lab config, we can only currently select a single system. In the full setup later on, this would include various systems to which the user is or has access, depending on community membership and other attributes. We can select what type of what flavor we want to have, so the size of the instance, and then we can start it. And now I have to cover about 20 seconds for the instance to start up. We get all the log messages, which help users to identify potential problems, which also help us in terms of support, which you can reach down here at the bottom, already with a slightly pre-filled email. If you copy the log into that email and let us know, hey, I've found a problem, that's probably the best and easiest way to let us know and guide us to the root cause of the problem. So what we then have is a Jupyter Lab with where I already placed a quick start. What you will have noticed, I created a new lab, but still I have the quick start in here. This is because we do provide for persistent storage also. So if I return with the same user ID and start a new lab, I still have the contents of my previous session, and I can share this content also with previous sessions. I just want to quickly go through, because I'm not demonstrating Jupyter itself here, just quickly go through basic imports. So what I want is, many people will know that NumPy SNP, matplotlib pyplot SPLT, and we want matplotlib plots to show inline. So we do that, and we we run the next thing, generate several random numbers. What's happening here? Okay. And a brief diagram of these random numbers. What I also want to show is that it is possible to access resources on the web. So we can download data from the internet. And for the sake of time, I decided to use Seaborn, which loads data sets from the internet. And one can easily show the contents of this and also create nice figures. And as you go along, you can, of course, document all what you all do, as I've done here in downloading data and up here using Markdown syntax. And you can probably go much more fancy in terms of LaTeX formulas and things like that. Other than that, you can look at the kernels that are running. There are plugins supported, actually quite a large list of plugins, which would deserve a whole new training that I'm not going to do today. So this was my short demo of the already existing Jupyter4NFDI infrastructure today. I'm going to stop sharing and share my slides again. Hope you can see them. I cannot. No, there we have them. So this was my short demo, and final slide, I believe, a brief outlook on what on the months to come and hopefully years to come in the Jupyter4NFDI infrastructure. So what we want to provide is a sound, sustainable, and user-friendly infrastructure, including training material or providing an infrastructure for conducting trainings by communities, by the consortia, scaling certainly to the national level, and you see it at the very bottom, and embedding in the European Open Science Cloud can also be envisioned. We certainly want to support more consortia within NFDI, more than we currently support, and all interested consortia are invited to get in touch with us. Even though in the initialization phase, we have to do some expectation management. We cannot answer all requests right now. So that will take some time. But over time, we're confident that we can build up a good and sound infrastructure for many users in the NFDI. Data management will probably play a role when it comes to using resources at various sites, because data may be available at one site and you can, for whatever reason, only work on another site. Then we need to be able to transfer data or resolve references, depending. This may or may not be a task for Jupyter4NFDI itself, or other services, depending on how one accesses this data. Ample training material should be created. This is also part of every Base4NFDI project about the services itself, as well as, and I already mentioned it, community trainings that can be conducted on this infrastructure. And with that, I would like to thank you for your attention, and I'm open for questions now.
So thank you very much for this interesting talk. I will stop the YouTube stream now, and then we can go to the question and answers. For our spectators on YouTube, we have a summer break now, and we are back on 2 September with